I will start with the GWI in general. We are a non-profit organization founded in 1937. We have at the moment around 70 employees. We are in Essen in North Rhine-Westphalia. We have more or less three main departments: research, education, and test laboratory. Research, I am part of this department, as you can imagine. And the test laboratory is testing for certification for the German market for gas applications. And the education department is teaching people who are dealing with gas or gas-related technologies, so that they know about safety issues and how to handle them, etc. We have a lot of members from the industry. A few very big ones you probably know, like E.ON or Fissmann or Weiland, and general or a few distribution grid operators, and so on. And of course, we have also partners in the research field, so it's called a research network. And you will see a lot of known names like PTJ or Fraunhofer Umsicht or Duisburg Essen, the university, and so on. I will show you a few current projects of the GWI so that you will have a general idea in which fields we are working at the moment. And one of a very big project we had in the past was a project 100 CHP units in Bottrop. We installed 100 CHP units in Bottrop in normal residential buildings, or more or less residential and service buildings like kindergarten or small department buildings, and of course normal residential buildings. All these buildings get an energy monitoring system, so that we get every 5 minutes data from the energy production, consumption. And energy means, in that case, electricity and gas. We got a lot of data out of this project, and we compared the new version with the old version. So it means like a gas boiler or oil boiler with the new CHP systems. And we showed the amount of CO2 which could be saved using these kind of technologies. The CHP units, the technologies we used were fuel cells, Stirling engines, and Otto engines. So we used a range of CHP units. Another project which is funded by the BMWI, the German Ministry of Economy and Energy in Germany, is the project ENQM, Energy Optimized Quarter Margaretenhöhe Essen, which is a historical restricted or historical protected district in Essen, where we show several technologies to retrofit these buildings because they are protected. And we're building up a model for the whole quarter to simulate it, to present the different approaches, not only on the building levels, on the district level. The last project I want to show you is the Store and Go. In Store and Go, we are dealing more or less with power to gas, but power to gas on a large scale, megawatt scale, all over Europe. We are investigating the different technologies, their integration, their interaction with the grid, and so on. It's another project where we are simulating the electric grid, the gas grid, and the district heating at the same time in the transient way to see the interaction and the possibility to integrate renewable energies into the German energy grid, energy system. In which part the GWI is working. We're working in the Work Package 1, Work Package 2, Work Package 3. And the Work Package 1, we are testing several technologies in our demo building. And as you can see, we have a multi-family house at our site. which is a real a multi-family house where we can install several technologies which are used in residential buildings. The building is equipped with an energy monitoring system. So we can test the system in a realistic environment. And then we have also test rigs where we can measure precisely the efficiency and so on. In work package 2, we are going to testing a battery system in one of our test rigs or in the demo building, we will see. And we are providing the project with real data from buildings, which means low profiles for electricity, low profiles for heat demand in, I think, minute steps, I think, we agreed on that, I think. In work package 3, we will provide the project also with a test environment for the bigger electricity storages on our site, because we are building up a so-called smart microgrid on our test site. We have electrolyzers, we have fuel cells, we will have PV in the next year, I think. And we have different CHP units with different sizes. And all these systems are connected with each other, and we have the measurement systems there and the data acquisition to show the whole system. And this is a small overview of the things we are providing the project. On the lower side, you can see the load profiles. And on the right side, this is an overview of German building types. And there are different energy consumption levels and so on. And in the end, we will simulate the different systems in interaction and integration in the different kinds of residential environments and districts. Simulation, what does it mean? We will take the real buildings and start to discretize them and to model them, and then in the end we will have a simplified model of the building. This, for example, is one floor of a multifamily house. This is the floor, the house stair, the stairway, and these are two flats, and we simplified the realistic one. You can see these are one flat with several rooms, but we simplified it so that each flat is one room with an average temperature which is set by the behavior of the people who live there. I try to do it in a short way. And that was an overview from myself, and thank you very much.